So, very first question was from a 2019 November paper, and it said, Michaela sits on the beach and writes her name over and over again in the sand. So she's writing Michaela, 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 Michaela. If Michaela continues this pattern, determine the 2019th letter she will write. And then the second question, determine the probability of the letter M being selected out of the 2019 letters. I'm going to give you, how many human minutes do you need here? Three human minutes? That feels fair. 3 Earth human minutes. Boo, that's just lazy. You can count yourself. I told you would be cross with me. I knew it. Please don't write out Michaela to like till you get to 2019 letters. Think of a quick, smart way to do this. Okay, Uya's going with C. I'm not going to say anything. I'm giving you time. Khulani, that's actually very good thinking. Where you're going is very good thinking. Raboho, you can't live without a calculator. Yeah, the 252,38 is actually a very good way of starting to think about this. Sia, maybe. If your coach is going to fight for you, there's a chance. Hold on to the chance. Well, Abu, I don't want to tell you just yet. I'm giving people a chance. Okay, so some are saying I, some are saying C. I'm giving you 1 more minute. Actually, I'm going to give you 2 more minutes because I also want to have an answer for 8.1.2. Okay. Last human Earth minute. Let's go. So the reason I was saying that that's good thinking is we've got the name Michaela, right? And there are 8 letters in the name Michaela. So if we know that we're going to have 2019 letters, a good way to start would be, so this is for 8.1.1, 2019 divided by 8. And what we land up getting is this 252,38, right? So we know that we're going to have Michaela written out in full 252 times. So we're going to have the whole of Michaela written out 252 times. Then I have to think, well, what if we take our calculator quickly? So take your calculator quickly and you say 252 times 8. What do you get? You should get a nice round number. Come on. There we go. Okay, so we know that that takes us up to letter 2016, but I need 2019 letters. So this will be letter 2017 will be an M, letter 2018 will be an I, and letter 2019 will be a C. So those of you who got C, well done. And if anyone doesn't understand that, please let me know. Then for 8.1.2, it's saying determine the probability of M being selected out of the 2019 letters. Now we know Michaela only comes up once, the M in Michaela. So we know over here, I'm going to have 252 M's, and then I've got another M. So I'm going to have 253 M's out of 2019. How did that question go? Me, bleh. Somewhere in the middle? Me, okay. So when we took the 2019 and we divided it by 8, we got 252 comma something. So we know that we're going to have definitely got 252 times of having Michaela written, right? So if we multiply that by 8, we get 2016. So that means that this A is going to be letter 2016 because I'm going to have Michaela written out 252 times. 2016 is going to be the letter A. So then 2017 is going to be my next letter, which will be M, and then I, and then C. So we're just trying to work out which one it's going to be. No worries. Okay, screenshot if you would like. Your next question is a Venn diagram. Sure. Tirimalo, can you tell me where you're getting confused so I can help explain a bit more? 8.1.1. Okay. So we don't want to have to write Michaela out 2019 times. That's going to be a problem for us in the middle of an exam. So if we look, we can see that the name Michaela has got 8 letters. So we're going to have 8 letters, and then it's going to repeat. 8 letters, and then it's going to repeat. And then 8 letters, and it's going to repeat. So I want to find out how many times Michaela is going to repeat itself. In order to do that, I'm going to take my total letters and divide it by the number of letters in Michaela. And that tells me that I'm going to get the whole word Michaela written 252 times. So I'm going to have Michaela, 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 Michaela 252 times. Now I need to get to letter 2019. So I need to figure out which letter this is going to end on. So if I say the 252, which is what we got over there, times by 8, that gives me 2016. So that means I've had 2016 letters after writing Michaela 252 times. But I need 2019 letters. So my next letter will be M, my next one will be I, and then 2019 will be C. Okay, cool. Okay, Venn diagram for the win. In a class of 40 learners, so also I've put the marks here. So this was all part of that same exam. So in total, you had the 2 marks up the top, the 2, 4, and now you've got an extra 9. So it does add up. In a class of 40 learners, the following information is true. 7 learners are left-handed. 18 learners play soccer. 4 learners play soccer and are left-handed. All 40 learners are either right-handed or left-handed. For the first 4 marks, draw a Venn diagram. Testimony, I will pop up straight after this question, okay? So just to make sure you're all okay, we've got people who are right-handed, people who are left-handed, and people who play soccer. Very excited to hear about your Venn diagrams, to hear about your answers. Is 3 more minutes enough? Let me know. Not for all the questions, but just to draw your Venn diagram. If it's not, let me know. It's weird. I'll take that. So in this question, it's actually sneaky. You can do it two different ways. You can do it with 2 circles and you can do it with 3 circles. So, oh yeah, it depends on how you draw it. You can actually draw it 2 different ways. You can draw it with just left hand and soccer, and then you've got your outside area, or you can draw it with 3 circles, left hand, soccer, and right hand. So these are your options. Either, and then out here, you've got your people, or something like that. Those are your 2 options. Okay, last minute to draw your Venn diagram, and then I'm going to draw it on the board so that if you struggled, you can at least answer the questions that follow. Oh, that's not a great circle. Okay. Speak now or forever hold your peace if you do not want me to go over these circles. Okay. I'm going to do the 3 circles first because that would have been my instinct. Please withheld. Okay. Peace withheld. Oh, peace withheld. Got you. Okay, cool. So we can't have someone who is both right-handed and left-handed because they told us that they are either one or the other, right? So we know we have none that are going to be all 3 because we have none who are going to be left-handed and right-handed. Okay. Now we can start going through some of this information. We know we have 40 people altogether. Cool. We have 7 learners who are left-handed. So I'm going to just put that 7 over there for now. And then we have 18 learners who play soccer. And we have 4 learners who play soccer and are left-handed. So if I'm going to have 4 learners there. Yeah, you can put zeros. If it's a 0, it's a 0. Like there can be nothing there. There can be nothing that matches. Did I just blow your mind a little bit? And now we had 7 who are left-handed. So we're going to say 7 minus 4, which means we're going to have 3 who are over here. And over here, we're going to have our 18. Oh, sorry. We don't have any who are just playing soccer. So this is also going to be a 0. And then we're going to have 18 people who play soccer, but we had 4 over there. So we're going to have 14 over here. So now we have 18 people in total who are playing soccer. But we have 40 people in total, which means we're going to have 19 people who are right-handed. Did I do that math wrong? 18. I think that's right. I know, it's a weird Venn diagram, I know. Four plus 14 is 18, plus 3 is 21, 21 plus 19 is 40. That's right. Got me questioning myself here, guys. The easier way to do this one would probably be to do it with just 2 circles. So let me show you, let me make this one a little bit bigger. I think that this would have been the easier way. So basically, we'd be looking at people who are left-handed, people who play soccer, and then in total, we have 40 people, right? So this way, we still would have had 7 who are left-handed and 18 who play soccer, but we have 4 that are both, which means we have 3 who are only left-handed and 14 who are playing soccer. And then if we add those up, we know that we're left with 19. And so we would have 19 chilling in the background. And those 19 would be our right-handed people. I think that would have probably been the easier way. But the key here is, even if you are really struggling, draw something, because the follow-on questions, you will get accuracy marks based on your Venn diagram. So even if your Venn diagram is wrong, maybe you would lose those marks, but you won't lose all of the marks. Yeah, I think the 19 is in the right place, because the 19 is talking about people who are just right-handed. Yeah, okay, so let me explain where that one came from. So in total, I see what you're saying. I don't actually think we have enough information for the 14 to be here or here. I think it could be either one. I don't think they've given us enough information for where that 14 should be if we've done it with 3 circles. If we've done it with 2 circles, then we know that our 14 is going to be over there. But based on the information we've being given, I think regardless of where you put your 14, as long as it was within the soccer circle, you would have gotten a mark. Because the way that they have the marks are, you got 1 for the 3, 1 for the 4, 1 for having 19, and then they had, they have? S, and then they've got S being 18. So the fact that the sum was equal to 18. So regardless of where your 14 was in there, they would have given you the mark because of the unclearness of the question, if it helps. Okay, so let's go, so that we're all being consistent. Let's work on this one. That's fine. You must do whichever one you feel better with. But see if you can get these answers for me. I will mark accordingly. To try these ones for me. Okay. Abu, I'll take that. Yes, I agree with your answer, Uyanda. How many learners in the class are right-handed and do not play soccer? 19. Good. Keep going. 2 more questions. And then another Venn diagram. Oh, Uyanda, you're mixing and or. So they can be left-handed or they can play soccer. Here we go. 21 out of 40. Now they've asked for a probability, so we have to give it as a fraction or a decimal or a percentage. And the last one, that they are right-handed and play soccer. Yeah, here we go. Right-handed and play soccer would be 14 out of 40. Because these people are right-handed and don't play soccer. These people are left-handed, which means these people must be right-handed and play soccer. Or if you're looking in the 3 circles, then you can see your 14 over there. Feel free to take a screenshot. I will give you a minute to take one, and then I'm going to scroll up quickly for Desdemonia to take a screenshot of our first question. And then I'm going to go to another Venn diagram. Okay. All right, Desdemonia, take your photo. Cool. Okay, nice, easy question before we do a Venn diagram. in a box. And these are all from the exam. Well, this is not the same exam. This is another end of year exam. In a box, there are 7 bar ones, 5 arrows, 6 crunchies, and 2 PS bars. Morgan takes one at random, keeps it, and draws a second one. Determine the probability that she will get a bar 1 for her first draw. Don't overthink it. Yenda, something's happened with your maths there. So if we have 7 bar ones, 5 arrows, 6 crunchies, and 2 PS bars, that means I have 20 chocolates in total. But remember, when we're doing probability, it's out of the whole sample space. This is her first draw. So for her first draw, there are still 20 chocolates in the bag because she hasn't drawn any yet. Okay, so first draw, there are 20 chocolates in the bag, and there were 7 bar ones. So we have a probability of 7 out of 20. For B, I'll give you another minute or two. What's the probability of her getting another bar 1 on the second draw? Tristan, I haven't heard from you in ages. Hello. Yes, you are absolutely right. The probability of getting a second bar 1 in this case would be 6 out of 19 because I'm going to have 19 chocolates left because I've drawn one out and I already drew 1 bar 1. So I only have 6 bar 1s left. Cool. Nice, easy question to get your confidence up before the Venn diagram. Yes. Okay. So this was the whole question in the exam. A butterfly collector has collected 40 butterflies. All of them have at least one of the following characteristics: 7 long wings and red coloring. 5 have long wings and short antenna. 9 have red coloring and short antenna. 7 have long wings only. 6 have short antenna only. 8 have red coloring only. And they've told you to make long wings L, red coloring R, and short antenna A. So we're going to have a Venn diagram with 3 circles where we're looking at L, R, and A. For the first question, they've told you if X is the number of butterflies with all 3 characteristics, draw a Venn diagram and then determine the value of X. So they're telling you to make that X while you try and work this out. And then you got to work out what X is. I will give you time. Don't worry. Good luck. If you have questions, I'm here. No, it's not so bad. The more information they give you, the better. When you see these questions that have all these lines, just be grateful. Okay, getting our first answers in. I'm not going to say anything yet. I can confirm that one of the answers that has been given is correct. Let's see who agrees with x equals 2 or x equals 1. One of those is correct. Okay, I'm giving you 1 more minute. Okay, let's put everyone out of their misery. So let's go through our little Venn diagram. They've told us that 8 have red coloring only. So we know that that is going to be an 8 over there because they are the ones that are going to be only. They've told us that this is X. Okay. They've told us that, so I've done this one. They've told us 6 have short antenna only. So we know that this is 6. They say 7 have long wings only. So that's 7. 9 have a red coloring and a short antenna. Okay, so this is going to be 9 minus X. 5 have long wings and a short antenna. So this is going to be 5 minus X. And then 7 have long wings and red coloring. So 7 minus X. So we're going to put all of that information. So we have 7 plus 7 minus X plus 8 plus X plus 5 minus X plus 9 minus X plus 6 needs to equal 40. Who got to this point? Let me know. Let me know in the chat. Good. So what we should land up with over here is negative 2x is equal to negative 2, which means that x is equal to 1. So I think Uya was our winner in this round. So now that we know that that's 1, we can give all of these values. So now we know that that's 4, that's 1, that's 8, and that's 6. So for 8.2.2, determine the probability that a randomly chosen butterfly has red coloring, but not long wings. So red coloring, but not long wings. I'm going to give you a moment. So look at the ones that have red coloring, but not the ones that have long wings. So let's have a look. This circle are the ones that have red coloring, right? This 6, that has long wings, so we can't include them. That 1 has long wings, so we can't include them. These 8, they don't have long wings, and these 8 don't have long wings. So we're going to have 16 out of a possible 40. And then for the next one, has short antenna or long wings. So then you're looking at anything that has a short antenna or has long wings. Beautiful. 32 out of 40. Guys, I think our probability is getting better. I feel progress is happening. Are you saying, is it not 17 for this one? Yes, sure. Yeah, no, okay. Let me explain both of these again because it seems like there is some confusion. Okay, so Tristan, the reason that one's not 17 is because we can't include this 1 over here because that 1 also has long wings. That 1 has long wings and short antenna and red coloring, and we're not allowed to include anything that has long wings. So we can't include the 6 and we can't include the 1. We can only include this 8 and this 8. And so that's why that one's only going to be 16 out of 40, because we can't have anything that has long wings. Okay. Then Uyanda for B. If we are looking, if it has, let me get a different color happening here. If it has short antenna or long wings. So this one has long wings, so we can include it. This one has long wings, so we can include it. This one has long wings and a short antenna. This one also has both. This one has short antenna. So we're allowed to include all of those. Then we can also include this 8 over here because they also have short antenna. They don't have to have long wings. They just need to have short antenna or long wings. So we can add all of those values together. So we're going to say 7 plus 6 plus 1 plus 4 plus 8 plus 6. And we should get the beautiful answer of 32. If that doesn't make sense, so let me know. Okay, good. Okay, screenshot away if you would like one. I think we probably have time for one more then. Okay. A survey was conducted on the times people watch TV. in the morning, in the afternoon, and or the evening. 100 people were interviewed, and the following results were recorded. 15 watch at all 3 times of the day. 20 of those who watch in the morning also watch in the afternoon. 20 watch in the afternoon only. 25 of those who watch in the afternoon also watch in the evening. 8 watch in the morning and evening, but not in the afternoon. 28 watch in the evening only, and 6 do not watch at all. So we're going to have a Venn diagram with 3 circles. So we've got morning, afternoon, and evening, and you're going to have 100 people in total. Good luck. If you get the answer for 7.2.2 right, then you probably have figured out your whole Venn diagram, if that helps. I'm going to give you a few more minutes. I know there's a lot of words. Just try and work through it backwards. So like, 6 don't watch it all. So you've got 6 chilling out here, and you have 15 in the middle. So kind of work your way through there. Yay! Oyanda! You got the only! You got it! Yes! How are our Venn diagrams looking, guys? Are we making progress? Okay, so let's go through our Venn. 20 of those who watch in the morning also watch in the afternoon. Okay, so we know that if they watch in the morning, they also are watching in the afternoon. Where am I going to put that 20? Where's that 20 going to go? So 20 of the people who watch in the morning also watch in the afternoon. This little slice of pie over here, that's telling you that they watch in the morning and afternoon, exactly to and the 15 is saying morning, afternoon, and evening. So if they are watching in the morning and also in the afternoon, and there's 20 of them, then this is going to be 5 because between those two, we're going to have 20 in total. Yeah, exactly. Then they tell us that 20 watch in the afternoon only. So now we know that that's going to be 20 over there. 25 of those who watch in the afternoon also watch in the evening. So that means that this little segment over here, because that's afternoon and evening, that also needs to be 25, but we've already got 15, so that's going to have to be a 10. Okay. 8 watch in the morning and evening, but not in the afternoon. So 8 of them watch in the morning and in the evening, but they don't watch in the afternoon. And 28 watch in the evening only. So then we've got 28 over here. You know what, Abu? Why not? Why not? And then, hence, because we needed to use our Venn diagram for the hence calculate the probability that a randomly chosen person watches TV in the morning only. We're going to add everything up and it needs to equal 100. So then we find out that that number is going to be 8. So we have 8 out of 100. Exactly. And guys, we even have time for another Venn diagram. Look at that. It's just a win-win this evening. If you would like to take a screenshot, please feel free. And last Venn diagram of the night. In a class of 32 students, 20 take mathematics, 17 take history, and 28 take mathematics or history. Using a Venn diagram, determine how many students take mathematics and history. Oh, sorry, I didn't put this next question on the next line. And then what is the probability of students taking neither subject? And if that's it, we can come back to 7.3. Let's just do 7.2 first. So first mission is to draw a little Venn diagram with maths and history. Well, you can polish up with the X in the middle on this one, if that helps. Well, we'll see. We'll see. All right, last 2 minutes, everyone. All right. In a class of 32 students, so we know we have 32 students in total. So that's our end number that we need to get to. Okay. We have 20 who take maths and 17 who take history and 28 who take either maths or history, which means we've got how many chilling on the outside? If 28 take maths or history, we're going to have 4 chilling out here. Cool. Okay. If we make this x, then this will be 17 minus x, and this will be 20 minus x. So if we add all of these up, then we're going to have 20 minus x plus 17 minus x plus 4, and that all needs to equal 32. Or you didn't have to include the 4, and you could say it's equal to 28. Also totally fine. And you should get a beautiful answer. What's my beautiful answer, everyone? What does x equal? 9. So now we know that that's 9, which means that this is 8 and this is 11. And so we've done the first part, and then it says using a Venn diagram, determine how many students take maths and history. So that's this dude over here. So that's 9. And it didn't ask for a probability, just asked for people. 7.2.2, what is the probability of students taking neither of the subjects? That would be 4 out of 32. Very last question of the night. If 3 cards are selected from a pack of 52 cards, what is the probability that all 3 will be picture cards? Yeah, it is actually 2 marks in the paper because you get a mark for the numerator and a mark for the denominator. That's why I'm telling you, probability. Like, you can get lots of marks in probability. Like, you just don't hate probability. It can be your friend. .3 is a sneaky question. It's not one that we've actually spoken about yet. It's leading into our lesson that we're going to be doing on Thursday, which is our tree diagrams. So let me help with this one. When we're looking at probability and like an order of events, we have to take into account what happened the previous time. So in this case, there are 3 cards that have been selected. Okay. We know it's out of a deck of 52. It's asking what's the probability that all 3 will be picture cards. So the first chance of us drawing a picture card is 16 out of 52. That's the probability of our first card being a picture card. The probability of our second one now being a picture card would be 15 out of 51. And our third one would be 14 out of 50. But when we have to take into account previous events that have happened in probability, we multiply. So we say this probability times the next one, times the next one. And so in this case, we're going to get 28 over 1105. But don't be hard on yourselves because we are going to do this on